Now that we have discussed one aspect of variables in Python in our previous video, let's discuss the other aspect of variables as well. A variable in Python can also be considered as a container holding some value, or more specifically a reference that points to a container holding some value. When we say x equal to 10, first a container is created with the value 10 and x, the variable x, starts pointing to that container. So I'm showing you what actually happens. A container is created with the value 10 in it, and the variable x start pointing to that container. Clear, guys? So I'm repeating again what is actually happening. When you declare this statement x equal to 10, what is happening? A container with the value of 10 is getting created and x starts pointing to that container. Okay. Now let's change the value of x to 20. Now let's see what happens. Now Python will first look for a container which contains the value 20. If such a container is found, then x will now start pointing to that container. If no such container is found, a new container with the value 20 will be created and x will start pointing to the newly created container. Now, do we have any other container with the value 20 so that x can point to that container now? No, we don't have any such container. So in this case, what will happen? A new container with the value 20 will be created. So let's create a new container. So we create a new container with the value 20. Okay. Now what will happen? X will no longer point to this container. The container that contains 10 will no longer point to this container. What will happen? Now x will start pointing to this container. Correct? Now suppose we declare another variable. We declare another variable y, and that too has the value 20. Now what will happen? Will again a new container be created with the value 20? No. Here what will happen is that Python will first look around and check if any container is already existing with the value 20. So is any container already existing with the value 20? Yes, we already have a container with the value 20. Now what will happen? This newly created variable will start pointing to this pre-existing container. So let's do that. This newly created variable y will now start pointing to this container. So now x and y both are holding the same value and they both will point to the same container. That's what is happening. Now, if you want to assign the same value to multiple variables, how do you do it? Just let me erase this. Let's take a equal to b equal to c equal to 20. Now again the same thing happens. Python again first checks whether any variable is existing. First let me rectify this arrow. This was somewhat distorted. Now currently these two variables x and y are pointing to the same container that contains the value 20. Now we declared such a statement, a equal to b equal to c equal to 20. Now again the same thing happens. Python first checks whether any container already exists with the value 20. If it exists, then it does not create any new container. Rather, all these three variables will start pointing to the same container. Okay, let's draw that. So all these three variables A, B and C are now pointing to the same container 20. Now you may ask me that you are frequently using the term container. What this container actually is? These containers are nothing but memory locations. When we create variables, the value that we assign to them are stored in specific memory locations. This container are nothing but those memory locations. So generally what happens if you assign the same value to multiple variables, what Python does actually is, instead of creating new containers, instead of creating different containers with the same value, it holds a single container and makes all the variables which contain the same value point to that container only. So that's how it works. So we have a function called id in Python to check the memory locations or the addresses of the variables that the variables are pointing to. So by this we can actually verify what we have learned so far. Let's flip to Jupyter Notebook. Okay, so let's declare two variables. Variable 1 equal to 20, variable 2 equal to 30. Now what do you say, guys? Should these two variables point to the same container or they should point to different containers? So as they are holding different values and we have different containers for different values, so these two variables should actually point to different containers, right? We have two variables, like what are those variables? Variable 1 and variable 2. One container will have this value 20 and we'll have another container with the value 30, right? These were the two values we have currently. So variable, let's delete this. So variable 1 is 20 and variable 2 is 30, right? So variable 2 will point to this container and here we can say variable 1 is pointing to this container 20. So as these two containers are different, their memory addresses should also be different, and the id function, if we apply this id function on these two variables, they should give us different memory addresses, right? So let's see what they actually gave us. id variable 1 and id variable 2. Okay, so we print them separately. Okay, so let's run the cell. So according to our prediction, what should happen, as these two variables are containing different values, they are pointing to different containers, and as these are different containers, so the addresses should also be different. So let's see if that is happening. Yes, that is happening. You can see this address is quite different from this address. So we have verified this fact that two different containers are getting created. Now let's create another two variables or another three variables. Variable 3 equal to variable 4 equal to variable 5, and we assign all these three variables the same value as variable 2, that is 30. Okay, So all of now variable 2, variable 3, variable 4, variable 5, all of them are pointing to the same container, that is the same memory location. So the if we apply the id function on any of them, then all of them should give the same value, that is the same memory address. So let's see if our assumption is true or not. Let's try to apply the id function on all of them. 2, 3, 4 and 5. Okay, now let's check our assumption. Look, all of them are actually pointing to the same container, that is the same memory address.
So that's how memory management of variables happens in Python. Now friends, you may wonder what happens when a particular container or a memory location is not pointed by any reference at all. So let's say if we change the value of the variable 1 from 20 to 30, then along with the other variables, this variable also will start pointing to this container or this memory location, right? Now currently this container which contains 20 is not being pointed by any reference at all. In such cases, Python simply frees up or deallocates the memory. Now you may ask me how Python knows whether a container is being pointed by any reference or not. Python does that by a method called reference counting. Whenever a new memory location or a container is created, Python starts keeping a track of how many references are pointing to that container. Whenever a new reference starts pointing to that container, the count is incremented by 1, and when an existing reference starts pointing to some other container, then the count is decremented by 1. So just like what we did a few seconds back, we made this variable 1 to point to some other container. So the count was decremented by 1. Earlier the count was 1. Now as the count was decremented by 1, the current reference count for this container has reduced to 0. So whenever the reference count of a particular container or particular memory location reduces to 0, Python simply goes and deallocates or frees up that memory location. So this container will simply be deleted. That is, this memory will be freed up. So that's how it works. So friends, that's it for this video. If you have liked my video, please subscribe to my channel so that you get notified when I'll upload more Python and data science related videos. And please don't forget to like and share my video so that it reaches a larger audience and they also get benefited from it. Thanks a lot for watching.